your win-loss, your y variable, and I put it somewhere to the right so that it's my y values. The x is, you know, when you were little and you plotted x's and y's, x was the left and y is the right. So I'm just setting it up. What do you think could contribute to that win-loss percentage?
I would say kills percent.
Which is?
It's the third from the left after win-loss percentage.
Okay, so I'm going to copy and paste that and put that in my sheet. I didn't do this when I was younger, but learn from my mistake. If you don't do that, you'll corrupt your main file.
What's that?
Your main data sheet, don't ever mess with the main data sheet.
Oh, yeah.
Right, so what else do you think could affect win-loss?
Because if we're talking purely, because I was going deeper, so I would classify everything that's defensive, like defensive stats versus offensive stats. So what I put like
blocks?
Kills and hits.
Blocks per set? Blocks is defensive, right?
Yeah.
Okay, so let's just take that just to start with. All right, and you feel like these two things are going to predict your win-loss percentage. Let's see. Let's first take these two and scatter plot them. Yep, that's a pretty tight relationship. If, you know, like you'll know when something's wrong, it won't look nice and related like it does here, right? So if I put a line through it, a trend line through it, I can see how strong of a relationship that is by going to the metrics. I don't know. Let's do this. This is win percentage on the y-axis. And then over here, this is kills per win. Kills. I'll just put kills for now. And then I'm going to stuck on my axes. I want my chart. And put a line through it. Add trend line. And then you'll see down here where I can go down and just do the equation and the R square. The R square is 0.6. That means 60% of your variance for win-loss percentages is due to just the kills. 60% is explained just by the kills. Now, let's say I want to plot something else. I just click that thing. I want to now see whether the blocks have something to do with it. And just right-click it and go hide. And now you'll see the scatter plot of just the blocks. So now it's blocks on the x-axis. And that also looks, does this make sense? The higher the number of blocks, the lower the number of wins. That's what it's telling me. It's telling me there's a negative trend. The slope should be negative. And then it looks like it does it's like a negative relationship. It seems like you're going to have more losses the higher the number of blocks. Maybe you're spending all your time defending. I don't know.
Yeah, that's what I was trying to correlate whether defense is the actual winner of the game or offense.
It doesn't matter, but it does look linear. So now this justifies you using a linear model to model this, right?
Okay, so I would that for everything like set them down because
yeah. So you might want to like tone down the number of variables you're throwing in there. Like maybe take 2 would be good. Maybe there's something that you think is the biggest one, like Annabelle's. So for model 1, you could have all the variables that you don't think is the biggest one, and then put in the next for model 2, your biggest one, add in your biggest one, and see if the adjusted R squared jumps up, right? Like 60% of your variance is already explained with this, with the kills. That seems kind of important.
yeah.
So I would add in like just blocks and some other things first, and just try that as a model, as model 1, and then say, now I'm going to take my big one, my kills, and then put that in there. What is a kill in volleyball?
A kill is like when you hit the ball and it hits the ground before it hits the field.
That seems kind of like it's really important, right? So add it and see if your adjusted R squared jumps up. That says to you that that's a really important, like this is the most important variable that you have.
Okay, gotcha. Thank you so much.